Hey guys, welcome back. In the previous video, we did trigonometric differentiation. Next topic is implicit differentiation. So what is implicit differentiation? Before that, let us understand what do you mean by implicit function. Because we have some function, then only we are differentiating. Okay. So what of implicit function? Implicit function means the function in which you cannot make y as a subject. Okay. For example, the ordinary functions, let us say you have y is equal to x square plus 3x plus 2, right? So in this function, y is explicitly expressed in terms of x, right? Means y, you can make y as a subject, right? Making the coefficient of y as 1 and taking that y in the LHS, right? So this is called an explicit expression of the function with respect to x, okay, or in terms of x. But implicit function are those functions in which you cannot express y in terms of x, right? For example, you have the function, you can define any function like this: x square plus xy plus y square is equal to 2. Okay, so this, in this expression, you cannot express y in terms of x because you have the second degree curve also. If you are able to, if you are thinking that you can solve this equation, right? Solving means finding, taking this x as a constant. Okay, but here this is not a quadratic function, so you cannot use the quadratic formula minus b plus b square minus 4ac, because in this the coefficient of y in this is not a constant, it is again a variable. Okay, so you cannot solve this by using the quadratic formula making x as a constant. Okay, so meaning is that you cannot express the y in terms of x explicitly. Okay, so this is an example of implicit function. So how to differentiate this implicit function, we are going to study in this lecture. So there is it says that it involves differentiating both the sides of the equation with respect to x and then solving the resulting equation for dy by dx. So let us take this example: x square plus xy plus y square is equal to 2. So if you are taking, let us say, x square plus xy plus y square is equal to, let us say, let us take this as 6x. Okay, so what it says that differentiate both the sides of the equation with respect to x. So if I differentiate x square with respect to x, you get 2x. Then x is a function, means it is a variable, you need to differentiate this x, and also y is again a variable, a dependent variable whose value depends on x, right? So we will differentiate this y also with respect to x. Now how to differentiate y with respect to x? You cannot get any value, so you just write dy by dx. Okay, and as these two functions are in multiplication, we will apply the product rule. Okay, so first we will differentiate x. I will write this with a different color. I will differentiate this dy by dx of x and taking y as your second function or just a constant, and then plus differentiating y with respect to x, taking x as constant. This is your product rule. Okay, so you are differentiating this xy like this. Okay, what will the value of this, you will see in the next step. Again plus y square. So y square, as you know, y is a function of x, right? But here this is only y. So we will first differentiate y square with respect to y, and then we will just write dy by dx, right? This part is going to be little bit confusing and little bit difficult to you, that why y square can be differentiated like 2y into dy by dx. So it is just like you are differentiating any function, let us say t, right? T square, and t is again a function of x. So how you have used the chain rule, there is that you first differentiate this with respect to t, so you get 2t, and then what you did is you differentiate this t with respect to x by writing dt by dx. Okay, this we have done in the chain rule. Similarly, the chain rule will be applied if you are differentiating y square. So first differentiate y square with respect to y, whose value will be 2y, and then y will be differentiated with respect to x. So just write dy by dx. Okay, in the RHS, differentiate with respect to x again, so you will get 6. Now let us quickly see how this will end up. So 2x plus y dx by dx is just 1, means derivative of x is 1, right? So you will write this as just y plus x times differentiation of y with respect to x is just dy by dx. Okay, plus 2y into dy by dx is equal to 6. Okay, now you have to find out the value of dy by dx. So just combine the terms which involves dy by dx and leave those terms in the RHS and transfer the terms which are not involving dy by dx to right hand side, right? So dy by dx are the terms x dy by dx and 2y dy by dx. So keep these terms in LHS, transfer these two other terms in your RHS. So taking dy by dx outside as a common factor, you will get dy by dx multiplied by x plus 2y, right? And transfer all the terms to RHS, you will get 6 minus 2x minus y. Okay, now here you can, it is very easy, you can find out the value of dy by dx. Just transfer this factor to RHS in the denominator. So dy by dx is 6 minus 2x minus y, because consider this whole bracket as single factor. Student gets confused that they transfer this x plus 2y and make it as minus x minus 2y, that plus will become minus. No, consider this x plus 2y as a single factor which is in multiplication of dy by dx. Okay, so it will come in the denominator of 6 minus 2x minus y. So this is x plus 2y. This is the value of the gradient function or the derivative function, 6 minus 2x minus y upon x plus 2y. Okay, so let us quickly see again what we have done in implicit differentiation, that whatever is your implicit function, there is no need to separate y with x, right? So you just differentiate any term that involves x and y or even constant with respect to x. Obviously x will be differentiated by using the simple formulas that you have already done. X square derivative is 2x, xy, you consider this as a product of two functions which is x and y, right? When it comes for the differentiation of y, you just write dy by dx, right? And if it is not y, it is some exponent of y, whether it is under root of y, whether it is y cube or any power of y, you first differentiate that function with respect to y and then write dy by dx. Okay, this we have done in the second step, right? Now in the last step, you will separate dy by dx term and the other terms. Keep the dy by dx in LHS and transfer other terms to RHS, right? You can find out the value of dy by dx. Okay, so let us quickly see the other examples and how we can apply this in the basic results, that you can obtain the equation of the tangent and normal, value of the gradient at that point is this and that, right? These questions will come to each and every question, but type of functions and the method of differentiation will be different, right? So let us see what is your example. Says that you have an equation of a curve which is given by y cube plus xy is equal to 2. Find an expression for dy by dx in terms of x and y, right? So as you can see, this is our implicit function. You cannot separate x and y. So just quickly differentiate this with respect to y. So this is 3y square dy by dx. What I have done here is, again I am repeating, that y cube will be first differentiated with respect to y, whose derivative is 3y square, and then y will be differentiated with respect to x, whose value is dy by dx. Okay, plus this we have already done. Again, two functions x and y are in the product, right? So I am first differentiating x, writing y as it is, and then writing x as it is and writing dy by dx for derivative of y, right? In the RHS you have derivative of 2 is 0. Okay, Now combine the terms for dy by dx. So you will get 3y square plus x multiplied by dy by dx, taking dy by dx as a common factor and transferring minus y to other side, or y to other side, it will become minus y, right? So your value of dy by dx is minus y over 3y square plus x. Okay, this is gradient function. Now second part says hence, this is your first part. It says hence means using this, the value of dy over dx, or the answer of part 1, you have to find the gradient of the curve at 1 comma 1. So I just put the value of x and y as 1. Now you will notice here that whatever functions that we have done till now or previous to this implicit function, if you are finding the value of the gradient, you just need the x coordinate, right? Whatever derivative functions we have derived, whatever functions we have proved, or find out the gradient function, you will notice that it involves only x. There was no y in the gradient function. But implicit functions are a special type of function in which gradient functions also involves y. Okay, so you need both x and y coordinate as far as gradient of an implicit function is concerned. It is not always true. You may have a implicit function which do not have y in its derivative function, but most of the time you will see that you need both x and y. Okay, so just put the value of x and y in your gradient function. Put x is 1 and y as 1. You will get the value of dy dx as this is minus 1 upon 3 into 1 square is 3 plus 1. This is minus 1 over 4. Right. Next it says that you have to find out the equation of the tangent to the curve at that point. This is very easy. So equation of curve is y minus y1. Y coordinate is 1. Slope or the gradient of the tangent is minus 1 by 4, and x coordinate is again 1. So this is 4y minus 4 is equal to minus x plus 1. So 4y plus x is equal to 5. Okay, this is your equation of the tangent to the curve at the point 1 comma 1. Okay, it is very easy. It is just that how to differentiate an implicit function. Okay, rules of differentiation will remain same. Let us do another example. It says that differentiate this and hence find out the coordinates of any stationary points. Okay, now we are moving one step further, right? First we have found out how to differentiate this, what will be the value of the gradient, and then see, can we find out the stationary point too for any implicit function? Obviously there will be some bending in the curve. So let us see. First part is very easy. Again, differentiate this. X cube derivative is 3x square plus differentiating y cube derivative is 3y square into dy by dx. Please again do not forget to differentiate y lastly with respect to x. Okay, is equal to 3 times x dy by dx, differentiating y with respect to x, plus keeping 3y constant and differentiating x whose value is 1. So you will get just 3y. Okay, so I think we have done, or just let us find out the function dy dx, because after all we have to put in the second part the derivative function as 0. So as you can see, we can cancel these 3 from both the sides, right? Taking 3 common from both the sides, you can cancel these 3's, and then writing this as dy by dx terms will be having y square, and this is minus x is equal to y minus x square. You can check it. On RHS you have y, in LHS you have x square. Just transfer this x square to RHS, you will get minus x square, and dy by dx, this term you just transfer to LHS, you will get 3 minus x dy by dx, and y square dy by dx was here only. So dy by dx again is equal to y minus x square upon y square minus x. Now it might appear to you that we can take minus sign outside and then cancel out. No. Okay, you have to look at very carefully that here in the numerator degree of y is 1 and x is 2, but in the denominator degree of y is 2 and x is 1, right? So you cannot cancel this, right? This is your first part. Now second part says that we have to find the stationary points. In order to find the stationary points, we have to put the derivative function, which is y minus x square upon x minus y square, minus upon y square minus x. This we have to put equal to 0. Now there are two conditions. What are those? If it is 0, then either numerator has to be 0, right, or the denominator has to be infinite. Please do not think that either numerator is 0 or denominator is 0. Whenever there is a denominator, whenever there is 0 in the denominator, a thing we say is not defined. Okay, it will approach to either plus infinity or minus infinity. Okay, so we said it is not defined. It is a very big number. So means to say denominator cannot be equal to 0. Okay, so if any fraction has to be equal to 0, its numerator has to be 0. Okay, so we have here y minus x square has to be equal to 0. That means y should be equal to x square, right? Y has to be equal to x square. So these are not the stationary points, but what you have find out a relation, that if you have to find out the stationary point, there is a relation between the coordinates, that y coordinate will be equal to square of the x coordinate. There will be infinite number of such points where you will find that y is equal to x square, right? There may be 1 point, there can be 2, 3, 4. We cannot say exactly that how many stationary points are there. Okay, this we will find out by putting y is equal to x square back into the original equation of the function. Okay, these are just a relation of the between the stationary points, and also not between the stationary point, but in a point. What is the relation between the coordinates of the stationary point? Okay, so till now you haven't find out the coordinates exactly of the stationary point, but you have just find out the relation between the x and y coordinates of a single stationary point, or I should say for every stationary point. Okay, so let us put this y is equal to x square back into the function. Our function was x cube plus y cube, x cube plus y cube is equal to 3 times xy. Okay, so let us put this y is equal to x square. So I have here x cube will remain x cube, y is x cube, x square, sorry. So x square cube, okay, is equal to 3 times x, and y is again x square, right? So I have this x cube plus x raised to power 6 is equal to 3 times x cube, right? So you have x raised to power 6 minus 2 times x raised to power 3 is equal to 0. Okay, I hope I'm not doing that fast. You can pause the video and you can check whether the algebra is going in the right direction. So you can take out x cube common. Here I have again x cube minus 2 is equal to 0. Now you have 2 points. One is 2 factors, x cube minus 2 and x cube. So you have 2 stationary points, that either x is equal to 0 or x will be equal to cube root of 2. Let us check whether this x equal to 0 is any point, or is this value is acceptable or not. If we put x is equal to 0, you will get y cube as 0, so y is 0. Obviously 0 comma 0, which is an origin point, our origin, there is nothing wrong in the origin. So one stationary point you will get as your origin. Okay, so if x is equal to 0, y is equal to 0, and if x is equal to 2 raised to power 1 by 3, y will be x square, right? So here y is 2 raised to power 2 by 3. So these are the exact coordinates of stationary points, right? One is 0, 0. I should write with a different color. This is 0, 0 and 2 raised to power 1 by 3 and 2 raised to power 2 by 3. These are the stationary points, only 2. Okay, and I think there will be only 2 points because your gradient function, when it was equal to 0, the highest degree of x was 2. So maximum value of the coordinates you can get is 2 only. Okay, means that method of that condition for the finding out the number of roots for any polynomial, whether it is of a single variable or of more than one variable, I think that remains true. Okay, so just go through these two examples again and the introduction of implicit function, and I think there is nothing more in this. You can define any other function also which involves trigonometric function, and then also in the angle there are implicit, means you can find out any, you can define any function, let us say y is equal to sine x square y, right? So again you cannot separate angles with this value y. Okay, so again you will differentiate this implicitly. Okay, so the method will remain same, rules will remain same, it is just that you will get a different kind of functions. Okay, so thank you very much for this implicit. We will do in the next topic parametric differentiation. Bye.